Let us start with the NEET and JEE concepts related to chemical kinetics chapter. See, chemical kinetics is an important chapter which comes under physical chemistry. Okay. So this is a branch of chemistry, or you can say it is a branch of physical chemistry which deals with the study of rate of a reaction, its mechanism, or you can also say as a mechanism of reaction and the different factors affecting the rate. These are the three concepts which are mainly involved in this chapter. Okay, so again I'm going to tell about the definition of chemical kinetics, or what do you mean by chemical kinetics, and what is the importance of knowing chemical kinetics and how much important it is in the NEET and JEE. Okay, so chemical kinetics is a branch of physical chemistry which deals with the study of rate, or you can say the velocity or speed of a reaction, how fast it is going to take place, and the mechanism of a reaction, as well as what are the factors which are going to affect the rate of a reaction. So rate of a reaction means, in this you are going to study the rate expression as well as rate law, order and molecularity, and even in the mechanism it comes. Factors affecting means nature of the reactants, concentration of the reactant, as well as products, and pressure, effect of catalyst, as well as temperature. So these are the main factors which are going to affect the rate of a reaction. So everything you have studied in detail in the theory part. So mainly what we have to concentrate here is about these things. Okay. So in NEET and JEE, the importance of chemical kinetics, you are going to get around 3 questions. If we get one theory, then we are going to get a problems. That is, 2 questions will be based on problems, because as it comes under the physical chemistry, mainly we have to concentrate on the problems. Therefore, if there are 3 questions, one will be related to theory and 2 will be related to problems. So that means we have to concentrate more on the problematic questions based compared to theoretical questions. It doesn't mean that you should not concentrate on theory part. If you understand clearly what concept exactly present in this, then only you can solve the problems. So initially we'll go step by step from the initial step, that is rate of a reaction. So it deals with these mainly 3 concepts what I have written here. So one by one concept alli ನಾವು ನೋಡ್ತಾ ಹೋಗೋಣ. So if you understand the basic and what exactly the concept present in these 3 units, sub-units present in this chemical kinetics, then easily whatever problem they ask, you can solve it. Okay, so let us go with the first one, rate of a reaction. Okay, what is the importance of knowing rate of a reaction? See, kinetics means the word kinesis, which is derived from the Greek, that is kinesis means movement ಅಂತ ಹೇಳ್ತೀವಿ. Kinetic energy ಅಂದ್ರೆ ಗೊತ್ತಿದೆ ನಿಮಗೆ, and kinetic molecular theory also you have studied. Movement ಅಂತ ಹೇಳ್ತೀವಿ. If a particle is hit by any substance or any other particle, it starts moving here and there in a zigzag manner, ಈ ತರ ಎಲ್ಲ ಹೇಳ್ತೀವಿ. So this is called kinetic movement, which gives an energy, inbuilt potential energy. So that is called kinetic energy, which is directly related to temperature, right? So what is the purpose of knowing rate of a reaction? For example, see, here I'll take an example of burning of sodium. Okay, so sodium ಬಗ್ಗೆ ನಿಮಗೆ ಗೊತ್ತಿದೆ. Can anybody tell why it is called highly reactive metal? Sodium. Can anybody tell me why sodium is called highly reactive metal, or what happens when sodium is exposed to atmospheric air? Yes, yes, it burns. Reason? It catches fire. What may be the reason? As you have studied in S block elements, already it is finished in your 11th class. So sodium na atmospheric air ge ನಾವು expose ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, and how we are going to store sodium? Quickly. Yes, kerosene ಅಲ್ಲಿ store ಮಾಡ್ತೀವಿ. It is highly vigorous, high temperature. Not exactly. See, okay. So burning of sodium. See, sodium will be stored in kerosene in order to avoid the contact of sodium with oxygen, because you know that it has only one electron in its outermost orbital. Since it is highly reactive and since it has unpaired electron which is highly unstable, in order to get the stability, it reacts with the atmospheric oxygen. So this as a result ಏನಾಗುತ್ತೆ burning ಆಗುತ್ತೆ. Okay, so it catches sudden fire. So what is the rate of a reaction? What is the rate of this reaction? Rate and how fast it is going to react with the air. What is the need of knowing the rate of this reaction? Okay, ಇದರ rate of reaction ನಾವು ತಿಳ್ಕೊಂಡು ಏನು ಉಪಯೋಗ? Because it happens within a fraction of minute, within a fraction of few seconds ಅಲ್ವಾ? ತುಂಬಾ ಬೇಗ ಅಥವಾ ಫಾಸ್ಟೆಸ್ಟ್ ಪ್ರೋಸೆಸ್ ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು ಇದನ್ನ. ತುಂಬಾ ಫಾಸ್ಟ್ ಆಗಿ ನಡೆಯುವಂತಹ ರಿಯಾಕ್ಷನ್ ರೇಟ್ ಅನ್ನ ತಿಳ್ಕೊಳ್ಳೋ ಅವಶ್ಯಕತೆ ನಮಗೆ ಇರೋದಿಲ್ಲ, because it happens within a few seconds and few minutes, a fraction of seconds ಅಲ್ಲಿ ಅದು ಹೋಗ್ಬಿಡತ್ತೆ. So therefore knowing the rate of these kind of reactions is not useful. ಇದನ್ನ ನಾವು useless ಅಂತ ಹೇಳ್ಬೋದು. So not ರಿಕ್ವೈರ್ಡ್, ನೆಸೆಸರಿ ಇಲ್ಲ ಈ ಥರದ್ದು ತುಂಬಾ ಫಾಸ್ಟ್ ಆಗಿ ನಡೆಯುವಂತ ರಿಯಾಕ್ಷನ್. ಇದು ಒಂದು ಕೇಸ್. ಅಂಡ್ ಇನ್ ಸೆಕೆಂಡ್ ಕೇಸ್, ಇಫ್ ವಿ ಟೇಕ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್ ಆಫ್ ರಸ್ಟಿಂಗ್. See, if you buy some things which is made of iron, whether it is of good quality or bad quality, it takes some time to undergo rusting, which is again nothing but the reaction with atmospheric oxygen. Okay, ಇಲ್ಲಿ combustion ಆಗುತ್ತೆ, burning, ಇಲ್ಲಿ rusting ಆಗುತ್ತೆ. So this is a very slow process, slowest process ಅಂತ ಹೇಳ್ತೀವಿ. Okay, so the knowing rate of these type of reactions is also useless, because it may take months, it may take years together. Okay, so ತುಂಬಾ ವರ್ಷಗಳ ಕಾಲ ಹಿಡಿಬಹುದು ಅಥವಾ ತುಂಬಾ ತಿಂಗಳು ಹಿಡಿಬಹುದು ಇದು ರಸ್ಟಿಂಗ್ ಆಗೋಕೆ ಅಥವಾ ಬರ್ನ್ ಆಗೋಕೆ ಅಲ್ವಾ. ಸಾರಿ, ಇಲ್ಲಿ ಬರ್ನ್ ಆಗೋಕೆ ತುಂಬಾ ಕಡಿಮೆ ಟೈಮ್ ತಗೊಳುತ್ತೆ, ವೆರಿ ಶಾರ್ಟ್ ಪೀರಿಯಡ್, ಶಾರ್ಟ್ ಟೈಮ್ ಅಲ್ಲಿ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ taking very longer period. So there is no requirement of knowing the rate of the reaction like this. So ಹಾಗಾದ್ರೆ what is the importance of chemical kinetics ಅಂದ್ರೆ, we have to go for a reactions which are taking time of moderate period. So moderate time ಅಲ್ಲಿ ನಡೆಯುವಂತಹ reaction, so neither very short nor very longer period. ಸೊ ತುಂಬಾ moderate time ಅಲ್ಲಿ ನಡೆಯುವಂತಹ reactions ನ rate ಅನ್ನ ನಾವು ನೋಡ್ಕೋಬೇಕಾಗುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಹ್ಯಾಬರ್ಸ್ process ಆಗಿರ್ಬೋದು, that is hydrogen reacts with nitrogen to give rise to ammonia. Okay, ammonia ಆಗುತ್ತೆ. Right. So this is actually a reversible process. I'm not writing reversible arrow mark here because I have to get a product, right? So ಇಲ್ಲಿ ನನಗೆ product ಬರುವಂತದ್ದು very important. So that's why I have not written the reversible reaction. So soon after getting a product, I'm going to remove it from the container. So then I can avoid the reversibility of the reaction. So this you have studied in equilibrium chapter, right? So if we use catalyst, proper catalyst like iron flakes and the promoters, then the rate of the reaction at moderate pressure and temperature can be fastened. Okay, so ಈ ತರದ ರಿಯಾಕ್ಷನ್ ಗಳ ರೇಟ್ ಅನ್ನ ನಾವು ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ತಿಳ್ಕೊಂತ ಹೋಗ್ತೀವಿ, how fast it is going to take place. Okay, so neither short time and long time, we have to concentrate on the reactions which are occurring in a moderate time. So this is the importance of chemical kinetics and knowing the rate of a reaction. So what do you mean by rate of a reaction? See, rate of a reaction can be defined as, or rate can be defined as the amount of or the concentration of the reactant, the decrease in concentration or amount of the reactant, or at the same time you can also say it as an increase in concentration of the product. ಪ್ರಾಡಕ್ಟಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಲ್ಲಿ ಇನ್ಕ್ರೀಸ್ ಆಗುವಂಥದ್ದು ಅಥವಾ ರಿಯಾಕ್ಟೆಂಟಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಲ್ಲಿ ಡಿಕ್ರೀಸ್ ಆಗುವಂಥದ್ದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, ರೇಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಅಟ್ ಎ ಪರ್ಟಿಕ್ಯುಲರ್ ಇಂಟರ್ವೆಲ್ ಆಫ್ ಟೈಮ್, ಅದಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, I have taken a reactant here. It is going to produce a product. So after some time, what happens? Slowly the concentration of the reactant is going to reduce. Meanwhile, the product's concentration is going to increase. So at a particular interval of time, ಇಲ್ಲಿ ನಮಗೆ time requirement ಎಷ್ಟಿದೆ ಅಂತ ನೋಡ್ತೀವಿ. So this has two types of representation, that is average rate of a reaction and instantaneous rate of a reaction. ಎರಡು ತರದಿದೆ, average and instantaneous. Average is the particular time. For example, 5 ನಿಮಿಷ ಅಥವಾ 10 ನಿಮಿಷ 15 ನಿಮಿಷ ಆ ತರ ಆಗ್ಬೋದು, ಅಥವಾ 1 hour ಅಲ್ಲಿ ಎಷ್ಟು ರಿಯಾಕ್ಟೆಂಟ್ ಪ್ರಾಡಕ್ಟ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಿದೆ, ಲಾಂಗರ್ ಟೈಮ್ ಡ್ಯೂರೇಷನ್. Okay, whereas instantaneous is particular. For example, ನೋಡಿ 0 seconds ಇಂದ ನಂಗೆ 80 seconds ತನಕ ಎಷ್ಟು ಪ್ರಾಡಕ್ಟ್ obtain ಆಗಿದೆ, ರಿಯಾಕ್ಟೆಂಟ್ ಇಂದ ಪ್ರಾಡಕ್ಟ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಿದೆ, between this time interval 0 to 80 seconds. So this can be considered as average because see, ಇಲ್ಲಿ 0 ಇಂದ 1 second ಗೆ ತುಂಬಾ ಸ್ಲೋ ಇರಬಹುದು ಪ್ರೋಸೆಸ್, 1 in the second. When it comes to nearer to the final destination, that is 80 seconds, when it is at 70 seconds, the reaction may be very fast. So it is difficult to find out exactly how fast it is going to occur but at each particular interval of time. So better it is instant. If we go for instantaneous rate of a reaction, then it would be easy for us to understand how fast the reaction is going to take place at particular time. Average ಅಂದ್ರೆ ತುಂಬಾ ಗ್ಯಾಪ್ ಇರುತ್ತೆ, ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಅಂದ್ರೆ ಇನ್ಸ್ಟಂಟ್ ಅನ್ನೋ ವರ್ಡ್ ಮೀನಿಂಗ್ ನಿಮಗೆ ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರುತ್ತೆ. Okay, at that particular time interval, each and every second, each and every minute is very important to know how fast the reaction is going to proceed. So average ನ ನಾವು ಡೆಲ್ಟಾ ಇಂದ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ, ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಅನ್ನ ಡಿ ಇಂದ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. Okay, so if I have to represent a rate of a reaction by taking R gives rise to P, then rate can be expressed as rate is equal to minus dr by dt. Similarly, dp by dt. So here it is plus, because students, reactant concentration decreases, that's why negative, product concentration increases, therefore positive. Rate can also be expressed as rate is directly proportional to the molar concentration of the reactant to the power of their stoichiometric coefficient. So if we remove this proportionality symbol, we can use K. See, K is a rate constant here. K andreno rate constant. Okay, so this is all about the purpose of knowing rate of a reaction and the definition of rate of a reaction as well as rate constant and how we are going to know about this. Okay, so this is about the synopsis, brief explanation ಕೊಟ್ಟಿದ್ದೀನಿ ನಾನು ನಿಮಗೆ. ಇದರ ಬೇಸಿಸ್ ಮೇಲೆ ನಾವೀಗ ಕೆಲವೊಂದು ಕ್ವೆಶ್ಚನ್ಸ್ ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಹೋಗೋಣ. ಐ ಆಮ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ಟೆಲ್ ಆಲ್ ದ ಥಿಯರಿಟಿಕಲ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅಟ್ ಒನ್ಸ್, ಬಿಕಾಸ್ ನಮ್ಗೆ ಏನು ಈ ಥಿಯರಿಗೆ ಅಂದ್ರೆ ರೇಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ರಿಲೇಟೆಡ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಏನಿದೆ ಅದನ್ನ ಫಸ್ಟ್ ಸಾಲ್ವ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಒನ್ಸ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಟ್, ದೆನ್ ವಿ ಕ್ಯಾನ್ ಗೋ ಫಾರ್ ದ ಅದರ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್. ಓಕೆ, right. So let us see the MCQs. That is the multiple choice questions based on the basic concept, that is rate expression. So did you understand what I said? That is, what is the importance of knowing rate kinetics or chemical kinetics? ಗೊತ್ತಾಗ್ತಿದೆ ಅಲ್ವಾ? It is ways to know about the rate of a reaction of very fast and very slow reactions. So we have to go for moderate one. Understood? ಗೊತ್ತಾಯ್ತಲ್ವಾ ಏನ್ ನಾನು ಕಾನ್ಸೆಪ್ಟ್ ಹೇಳ್ದೆ ನಿಮ್ಗೆ ಅಂತ? Say yes or no? Yes. Okay, so let us see this. See, here are few questions based on the rate expression. This is very easy. Just concentrate on the question. First, you have to read the question carefully. Then you have to understand what they have given and what they have asked. If 3A gives rise to 2B. This is our reaction. ಏನಇದೆ? 3A is a reactant, 2B is a product. Then the rate of reaction of plus dB by dt is equal to, okay, ಅದು ಯಾವುದಕ್ಕೆ ಈಕ್ವಲ್ ಆಗುತ್ತೆ ಅಂತ, dB by dt, okay, ಅಂದ್ರೆ ಅದು ಪ್ರಾಡಕ್ಟ್ ಅನ್ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಿದೆ. ಸೊ ದಟ್ಸ್ ವೈ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ಪ್ಲಸ್ ಚಾರ್ಜ್. Okay, so that's why they have given plus charge.